Okay. The two different kinds of factoring that we're going to do today are going to be greatest common factor and then factoring by grouping. Okay. There are two strategies that you can use. So let's see here. One thing I do want to mention, all right, that I forgot to mention, or maybe I mentioned and I didn't correctly give you all the information anyway. Calculators. If you borrowed a calculator from the school, and you know who you are. If you don't know who you are, I can look it up and stuff like that too. But if you borrowed a calculator from the school, even if you're moving on to a math class next semester, you have to return the calculator to me and then resubmit a new rental form for the second semester. Okay. So even if you're borrowing a calculator and you have to rent it again for the next semester, you'll have to resubmit a rental form. Okay, so keep that in mind. All right, and again, I'll point out, I'll talk to those of you that have and stuff like that. All right, so you'll all need to, if you borrowed a calculator from the school, you'll have to turn it into me and stuff like that. Okay, all right. So let's talk about factoring here. Again, I'll say this is going to be GCF and by grouping. Okay. And I'm off the screen. There we go. Okay. So factoring is a skill that we want to kind of develop in mathematics. It's helpful for solving polynomials. It's helpful for like working with polynomials and stuff like that. So we want to be, kind of like comfortable with it, I guess, like that. Okay. So first, let's talk about just what a factor is. Okay. What is a factor, right? So a factor is a monomial or polynomial that evenly divides another monomial or polynomial. Right? And even by evenly divides, meaning there's no remainder or anything like that. Okay? If you need a little quick refresher about what a monomial is, what a polynomial is. So a monomial, okay, so the prefix there, mono, means what? One, right? Okay? So monomial, right? So like someone who speaks in like a monotone voice, right? When you speak in a monotone voice, you don't change or inflect at all. You just keep talking, like that. You don't, there's one way of talking. You don't change how you talk. Anyway, monomial, right? It's just a single term. Okay, so for example, like x, 3, even 3x, we call that one term. So like an x is a monomial, 3 is a monomial, 3x is a monomial. Okay? So it's a number, a variable, or a product of number or variables. That's a monomial. Number, a variable, or a product of numbers and variables. All right? Whereas a polynomial is a, let's say like monomials combined by addition or subtraction. Okay, so you take two monomials, add them together, that is a polynomial now. Okay, of course, if they might be like terms, they could combine together to become a single monomial again. But if they're not like terms, then they'll be a polynomial. Okay, and of course, when there's two monomials, we call that a binomial added together. When there's three monomials added together, we call it a trinomial. And after that point, we just call it a polynomial, right? Poly for many, kind of thing. So anyway, we've seen that with polygons, right? Okay. Just a little bit of vocab there. Maybe you guys already do that, but just in case. All right, so we'll do a quick example here with just listing some factors. Okay, notice I'm not asking for the greatest common factor. I'm just saying list some factors of the given monomials. Okay, so we'll kind of do this here together. So, all right. So, for example, we'll do the factors of the number 12. What are some things that are factors of the number 12? Avery?
12.
12 is a factor of 12. What else? 1. What else? 6. What else? 2. 3. 4. What else? Trick question. There isn't one. All right. So next one. How about 14y? What are the factors of 14y? Yeah? Avery? Y evenly divides 14y. What else? 2y. Is that what you said? 2y evenly divides 14y. 14y evenly divides 14y. 7y. 7. 14. 2 and 1. I think that's all of them. Okay. Okay. Last one here. How about 7x squared? Again, it's a monomial, right? It's a product of numbers and variables there. 7x squared. That is a monomial. One monomial there. Okay. What divides 7x squared evenly? 7x squared. 7x. 7. X. X squared. 1, right? Everything divides evenly by 1. Okay, good. Very good. Very good. Okay. So, a tool that we can use to help us factor something, okay, is the prime factorization. Okay, we've already kind of used this tree in the past. Okay, so let me just show you that here real quick. So factor, let's say we want to factor 36 into a product of prime numbers. Okay, factor 36 into a product of prime numbers. So if you get stuck, for example, if you look at like the number 36 and you're like, I'm not really sure how it breaks down, right? Well, or what we can divide it by. Well, you can take that 36 and you can break every number can be broken down into a unique product of prime factors. Okay, so for example, 36, what can we break that down into? 2 and 18. Okay, does 2 break down any further? It's prime, right? So we'll stop there. I'm going to circle it. Okay, 18, does that break down any further? Okay, 2 and 9 or 9 and 2. I'll do 9 and 2 there. I heard that first. Again, 2 we know, we already said doesn't break down any further. Does 9 break down any further? And 2, 3 and 3. Okay, do either of the 3s break down any further? Just 3 and 1, right? So not really any helpful way. So we say then that 36 is equal to, I'm going to put these in the kind of numeric order here, 2 times 2 times 3 times 3, or 2 squared times 3 squared, if you like. Okay? And that's known as the prime factorization. You rewrite something. Okay? As a product of primes. And it's helpful sometimes to do that when you're trying to find a GCF, or greatest common factor. Okay? So, let's talk about finding that greatest common factor here. Okay? I can remember back when I was in like school and stuff like that, and sometimes getting confused about like what the difference between greatest common factor and like least common multiple, and I would always get those like, I don't know, confused, right? I always like have to like rethink about it some. So again, greatest common factor, what you're looking for there is right in the phrase itself. Greatest, so that's the largest. Common, that means, you know, shared between two or more things, right? And then factor, and so that again, excuse me, the factor there is, you know, things that divide something evenly. So it's the largest thing shared between two or more things that divides them evenly, okay? So let's actually take, as an example here, the 7x squared and that 14y that we talked about earlier, right? if we look back at our list of factors that we've got here, what do they have in common? They both have a 7, right? Let's see if I can get this here. Okay. They both have a 1 in common. Do they have anything else in common? True, but the variables are different though, so we wouldn't say they're, yeah. So yeah. So those are it. That's it, right? Okay. So those are all of the common factors, right? These are shared by both of these. They're the common factors, but which one of those is the greatest? 7, right? Obviously it's 7. And so our greatest common factor here is going to be 7. Okay, greatest common factor there is going to be 7. Okay, if we instead wanted to like factor the GCF from each expression, okay, this is related to what we just talked about right there. So I'll do it this way. Let's say instead of 7x squared and the 14y is kind of separated, let's say we had them together as a single polynomial. Okay? We already know the GCF is 7, so I'm going to take a 7 out from both of these terms. Right? We're going to divide that 7 out. Well, if I divide the 7 out from 7x squared, what's left over? X squared, right? That's what's left over, right? 7x squared dividing out the 7 leaves just an x squared behind. If I take 7 out of 14y, what will be left behind? 2y, right? Because 14 divided by 7 leaves a 2, and the y is still there as well. We didn't factor that out. Okay? These two things are still equal to each other, but it's now factored, right? We've taken that 7 out. And so this is ultimately what we're shooting to do as part of our goal today, factoring out a GCF. All right, if you look at another one here, 3a to the 5th minus 18a to the 4th. It's not necessary when you go to factor out a greatest common factor from an expression or from a polynomial, it's not necessary for you to do it all at once. Okay? Of course, to save yourself time and writing and stuff like that, take out as much as you possibly can, you know. But let's just say hypothetically here, I looked at this and I just as a quick glance, I'm like, aha, both of these things have, they both have a 3 and an 18, so it means I can divide both of those by 3. So I'll take a 3 out, and that will leave behind a to the 5th minus 6a to the 4th. So again, it's not necessary for me here. It's not necessary for me to take out everything at once. I'll just take out a 3. Divide out a 3. Factor out a 3. What else do both of these terms, though, have in common? Avery? They both have, a's, and specifically a to the 4th, right? They both have a's, but we're limited by this a to the 4th here. So we'll factor out a to the 4th here. When we factor out an a to the 4th, it's going to multiply with that 3, leaving 3a to the 4th. A to the 5th divided by a to the 4th, what does that yield? A to the 1, or just a, minus. And if I take a to the 4th, factor that out of 6 times a to the 4th, what's left from here? Just a 6. Just a 6. Because a to the 4th divided by a to the 4th is 1, the 6 is still there. Is there anything left in common between the a and the 6? Anything in common between these two? No, they're now relatively prime to each other, we say. But there's our GCF right there. And we factored it. Again, these things are all equal to each other. Okay, they still mean or say the same thing, but we've now just factored. Okay, and again, the factoring will be helpful in the future there. All right, questions on any of that so far? Okay, so then let me take away this page and give you 2 to try on your own here. Okay. So, factor using greatest common factor. Okay, this will be for y'all to try. Now again, for any of these factors to be common factors, they must divide all 3 terms in number 1, and in number 2, any common factor must divide all 3 terms in number 2 there. Okay? So make sure that you're not just looking between any 2 sets of numbers. The common factor must divide all 3 of the terms in these cases. All right? And again, don't feel like you need to do it all at once. Take out a factor at a time if you need to, kind of thing. All right? Take out a factor of time. Okay. Let's see what we're able to come up with here. So, just lost it there. Actually, I'll take volunteers here. So how about for number 1, a volunteer? Stephen, what do you say?
You want me to tell you my answer?
Sure. If you want.
I got 9y to the second power.
Okay, so you factor out a 9y to the second, and then parentheses, what was left over then?
3y minus 2.
Okay, so 3y. Okay. When you factor the 9y squared out of the 9y squared, remember we're dividing. When you divide something by itself, what's the remaining part, or what's left over?
1.
A 1. So we're going to put a 1 in here, plus, and then what was left over from the 27y cubed?
3y minus 2.
3y minus 2. Okay. Can we do anything further from here? Emmanuel? The 1 minus the 2, is that what you're saying? Yeah, so 1 and minus 2, they're both numbers. So if we wanted to, we could combine those together in our little thing here to get it even more simplified and say it's going to be just 3y minus 1. You also could have subtracted the 9y squared and the 18y squared there as well first, and then factored and stuff like that. Okay, but there it is, simplified, or as simple as it gets. Okay? Questions on that, number 1? How about a volunteer then for number 2? How about a volunteer for number 2? What's the largest thing we can divide all 3 of those by? Madison, go ahead. 11. Okay, so when you factored 11 out, what was left over here? Uh-huh. Okay, yep. Did anyone take out a negative 11? So you could have, if you wanted to, maybe that's just your preference. You could have factored out a negative 11, which then would leave you behind a positive 10 z to the 6th, a positive 2, and then a negative 11 z squared. Okay, either one of those is acceptable. At any time, you can really factor negative out, or you don't need to factor negative out. It's really kind of a matter of personal preference there, I guess I would say, about whether you want to or not. Okay, I guess same idea here. Technically, we could have factored a negative out as well. Factored out negative 9 y squared and then gone from there. Okay, there's a pass there for you too, Preston. At 10, you have a doctor's appointment you're supposed to leave for, so just a heads up. Okay, cool. So then that's factoring by GCF. It seems like we're all pretty comfortable with that. So I want to do one more thing here and talk about factoring by grouping. Okay, this is a extension, I would say, of the factoring by using the GCF. Okay, factoring by grouping. Okay, again, this is just like factoring using GCF. Okay, you kind of think of like factoring using greatest common factor as a tool in our factoring toolbox, right? So oftentimes when you're in the wild and you're doing some problems in math, okay, the directions will just be something like factor this thing, right? And then you'll have to kind of like think about, okay, how am I supposed to factor this? I could use greatest common factor, and you look and see, is there a greatest common factor for me to factor? And you would do that, right? Or sometimes when you're in the wild and asked to factor something, you might want to try factoring by grouping. Okay, so here's an example of a factoring by grouping kind of problem. Okay, so again, our directions might just be factor the following. So in other words, part of the difficulty of these is not just knowing the process, how do you do greatest common factor, how do you do factoring by grouping, but part of the difficulty is also knowing when to use those tools, right? When to use factoring by grouping, when to use the greatest common factor. And that's something you'll have to, kind of figure out. Of course, your teacher should help you to discern those things, but eventually it's something you want to be able to do as well too. Okay. So, at first glance, if you were asked to just factor this, would factoring using the greatest common factor be helpful here? Why not? What's the greatest common factor for these four terms? 1, right? Okay, in other words, they're all relatively prime to one another. There's nothing in common between these. Okay? But, like I said, factoring by grouping is an idea here. So there's going to be some sort of grouping we're going to do. And in fact, the way we're going to group these things is like so. Okay? When we add in these parentheses, now let's consider just the first grouping that I've got here. Okay? That first grouping. Is there now a GCF just in that, or greatest common factor in that first grouping? A 3 and, bless you, x to the third, right? So we can factor both a 3 and an x to the third out. If I factor a 3x to the third from 3x to the fifth, what's going to be left over? X to the 2x squared. Okay? If I factor out a 3x to the third from 15x to the third, what's left over? 5. Okay, that was helpful. Plus, and now let's look at the second group that I've got here. Is there something we can factor out from 2x squared plus 10? A 2. So let's factor that GCF of 2 out, and we're going to be left with x squared plus 5. Whoa, the same thing. Okay. There's one more bit of factoring we can do here. All right. You see, we have kind of like one kind of like item here, one term I guess you could think of here. It's a product. I guess there is an addition in there, but I mean we kind of have a product here, we have a product here. Okay? What is in common between these two terms? The x squared plus 5. So we can factor an x squared plus 5 out of this and factor an x squared plus 5 out of this. If I take an x squared plus 5 out of this, what's left over? 3x cubed, right? If I take an x squared plus 5 out of this, what's left over? A 2. Pretty crazy stuff. And that is fully factored now. All right? That is fully factored now. All right? So I'm going to have you guys try one here. So try. So there's one for you all to try. Make sure I wrote it down correctly. Volunteer here, want to lead us through this one? All right, Avery, go for it.
So I did it sort of different grouping. I did 2x cubed and then 3x in a group, and the 14x squared and 21 in a group.
Okay, so you rearrange the term sum, all right? So plus 3x like that, and then plus 14x squared plus 21 like that?
Yeah.
Okay, so what'd you take out from the 2x cubed plus the 3x?
I just took the x out.
Okay, and that leaves behind
2x squared plus 3.
2x squared plus 3. Okay, and then how about from here?
Out of this one, I took a 7.
7.
And then 2x squared plus 3.
2x squared plus 3. Okay, and then both of them have 2x squared plus 3, so we can factor that out. And then you're left behind with x plus 7. Okay. Did everyone do it that way? Did everyone rearrange the terms like that? No? Okay. So, I mean, alternatively, I'm going to guess some of you guys probably went like this, right? You group the 2x cubed and the 14x squared, and then the 3x and the 21 together. Also a way to go, right? And you could factor out what from these first two here? 2x squared. Leaving behind what's left over? If I factor a 2x squared out of 2x cubed, we have a what left over?
X plus 7.
Yeah, x and a plus 7 there. And then factoring out of here, we can factor a 3 out, and an x plus 7, and then, look at that, x plus 7 times 2x squared plus 3 are left over. So same thing, right? Hopefully we should end up with the same thing. Right? let's look at one more here, and then I'll get you guys started on your assignment. Okay? So, 6x to the fourth minus 24x cubed minus 5x plus 20. So we group these first two together and group the second two together there. What can we factor out from that first group? Okay, yeah, 6, right, divides both of those, and x cubed would divide both the x's there, exactly right. So 6x cubed, and that would be left leaving behind then an x and then a minus 4, right? Now, from the minus 5x plus 20, you might say, let's factor out a 5. And so we're left with a negative x plus 4. Can we continue to factor this thing the way it's now written? Can we now factor out these two things? Why not? They're not the same, okay, right? And so if this happens in, a factoring by grouping kind of problem, you're stuck sometimes. Okay? What can we still factor out here, though, from this second group? Right? These are very close to each other. That's positive x minus 4. This is negative x plus 4. What can I factor out from here? Okay. Yeah, a negative 1. We'll factor a negative 1 out. Make this 6x cubed, it's ugly 3, x minus 4, minus 5, then leaves behind a positive x and a minus 4. And aha, they are the same. Now again, in the wild, when you're on your own and the problem just asks you to factor, okay, factor by grouping is a valid strategy. If you group and you factor and you get something that you can't, that does not match up, then maybe you need to still factor some more, like we did here, we have to still factor some more. Or sometimes you can't factor anymore, you just can't get these to match up. Then factor by grouping fails. Okay, so if you can't get your two factors, these remainders to match up, then factor by grouping doesn't work. But here it does, right? Here it does. So we have the x minus 4, and we're left with the 6x cubed minus 5. Okay, so, hello, Grace. So there it is, factor. Any questions on any of this? No questions? All right. So let me get you guys started on your assignment here. It will be on the Google Classroom. Okay, so I'll go ahead and get this posted on the Google Classroom. Don't forget, you also have a 10 marks that I may do Friday. Okay, if you didn't get to finish that up yesterday or you didn't start on it yesterday, make sure you're working on that. That one deals with, adding polynomials. Adding, subtracting, multiplying polynomials, I think, yeah. Okay, let me get this finished.